to discuss. Sean?
Could you do one of the bank turns ones with the angle, please?
One of the bank problems?
Yeah.
I don't like taking money out of the bank, so we're not gonna do one of those on the test.
Let's go.
I don't like taking money out of bank.
And the reason being is, I'm gonna say this. I love inclined plane problems for our previous units. But when we do inclined planes, we always put the x-axis on the slope. And I'm gonna be dead honest with you guys, that when I started doing this, and I said, well, now before we put the x-axis, which was equal to that surface, and then all of a sudden the normal force was the y-axis. Then, I looked for an hour and a half when I was trying to do this problem to verify why we cranked it so now the gravity force is the y.
Yeah.
And you know what? I'm not going to dwell on that, so let's just move forward and not worry about that.
Okay.
Pray that it's not on the AP test for you guys later, but I mean, I'll do one, but it's the same idea. It's just, I believe everybody gets the x and y axis, but it's and I just can't fathom why we can twist it, and I can't figure it out. So
Okay.
if I struggle with it, I'm not going to make you guys do it.
Okay.
So no bank questions for race cars.
Can you do number 4?
Number 4. We're looking at the review, right?
Yeah. And I did it twice, and I got the same answer both times, but it's the wrong answer. And I don't
Maybe
know
my
what I'm
answer's
doing.
wrong. You know me.
4 is a student in the chair.
What is the answer on the sheet? Because I don't have the answer key.
4.03 meters per second. For the line.
Yep. Can I ask what you got for your force of tension, Bailey? We're doing 4.
Like 1,387.
I got 902, so let's figure out where we're different. So 4 talks about a person sitting in a chair, combined mass of 75 kilograms, is attached to a 5-meter long cable. The person moves in a horizontal circle. The cable makes an angle of 58 degrees below the horizontal. What's the person's velocity? So we're saying that she's hanging on a chair on a swing. Probably draw that a little bit better. She's hanging, and we're going to call that the side of our deal. She's sitting here. This force of tension is given to us, right? No, that's what we're after. So we're after this force of tension. The length of this, where am I at? Is 5 meters, right? And the angle on the horizontal is 58 degrees.
Yeah.
So by the law of some geometry rule, we can say this is 58 degrees. We know that this is my radius. Radius is not the 5 meters, because the 5 meters is the length of that. So what I'm going to do then is say, hey, let's make my triangle, because every time we know that something is at an angle, we're going to draw a triangle, right? So we know here's my right triangle. So we have my hypotenuse here, sine is my y, and x. Okay? I'm going to look at this triangle in 2 ways. One, I'm going to say that I can, since I have the length of this hypotenuse, and I have this angle, can I figure out the radius right away? So I know that in this case, my radius is going to equal to what? L times the cosine of 58 degrees, right? And my L in this case is 5 meters. Times the cosine of 58 degrees will give me my radius value to be 2.65 meters. Okay? Because we talked about the fact that we can use this triangle for anything. I'm just going to say for length, because I want that radius. I just found that right away going, they're telling me it's not the radius, so I found that radius. Okay? Then as always, you want me to draw a force diagram. We've got our force of gravity, right? Force of tension. This is 58 degrees. And that's about all we got on there, right? So then I'm gonna say, if this is my force of tension, just to get it closer, then my question I'm gonna come back to now is, what is my force X in the net X direction? If I'm dealing with this object right here, by the way, they gave us the mass too, right? Or not? 78 kilograms.
75.
Maybe that's probably why our numbers are different. Number 4. I have 78 in my work, that's my problem. That could be a part of the reason why we're off a little bit. Because I have 78 in my work. Okay? So if we have that, the question we're always going to ask, the question we're always going to ask then is, can we figure out the force net in the X direction? What do we have here? What's the only X direction we have? This thing right here, right? Here's my X, here's my Y. So what is this X direction? So if this is my hypotenuse, here's my right triangle, what is this? Force tension is the hypotenuse times the cosine of 58 degrees, right? Now, when we're doing centripetal acceleration, and I'm going to keep it mostly when we're solving math problems to do it this way, except some roller coasters we're going to do this, right? Roller coaster I can't change, but when we're doing centripetal acceleration in this direction, where is the acceleration? In the X direction or the Y?
X.
In the X. So if the acceleration is in the X, this must equal mv squared over r. Right? Or mass times acceleration. Acceleration in centripetal is v squared over r. Right? Then, what is my force y in the y direction? What's my net force? Force of tension times the sine of 58 degrees, right? Because again, at this angle, we're saying, here's my y. That's it. Minus force of gravity. Is there acceleration going up and down? No. So is this equal to 0? Okay? So if that's equal to 0, now I can start looking at this and say, hey, can I say that my force tension, a sine of 58 degrees, is equal to Fg? Can you see this? Can you see this? I just want to make sure that if they're looking at this tonight, they can see what I'm doing.
Yeah.
I can make sure that I don't get any further over.
Yeah, that's good.
Okay, I'll sneak that one. All right, so ultimately I am looking for the velocity of this. So I look at my two equations. Once you know your x, y, and your x and the y, ultimately I'm after this right here. So when I look at this equation, because maybe I don't even need this, but when I look at this equation, I don't know my force of tension. I do know my mass, and now I know my radius. But I don't know v, so I have two unknowns here. Can't solve that problem. Okay? If I look at this, I don't know force of tension, I know this. What's Fg? Mass times g. Do I know mass? So could I solve, since this force of tension is in both of these, can I solve a force of tension here? Plug it back in there and then find velocity. Okay? So that's what I'm going to do. I'm going to solve for force of tension here. Force of tension is equal to mg divided by the sine of 58, if you can follow me on that. So Ft is equal to 75. So Bailey, if we're off, that's because of me right now. Gotta love my calclexia. Divided by the sine of 58 degrees. And I don't want to tell you my number because I use 78.
So I got
75 times 9.8 divided by the sine of 58.
75 times 9.8.
867?
Yeah.
Yes, 867. So, from this, can I now put this into here and solve for v? So FT cosine of 58 degrees is equal to mv squared over r. So my FT now is 867 newtons. Cosine of 58 degrees is equal to 75 kilograms. Times v squared is what I'm after, and my radius was 2.65.
867.
Oh, we're just trying to.
Solve for v.
Oh, no, for me.
So take some time and use your algebra skills to solve for.
Sean, what'd you get?
4.5 meters per second.
I got 4.03 again. Not sure how I captured that one when I had that wrong one here. Did everybody get 4.03 in their calculators?
I got it. You don't need to-
Does everybody understand how I got the physics here? Again, hey guys, one thing I want to say is that this is our third unit of force, okay? And I will admit that I could have done a better job in our first unit to really understand that everything in forces is net force. But I feel better now that we're in third unit that you guys need to, except for planet stuff and satellite stuff, we need to really make sure that every problem we put a diagram and show the fx nets and the fy nets. Because even if I go back to the last test, there was problems on there that you guys did not do this. Some people. So make sure you're in a habit of always looking. What's the force going on in the x direction? What's the force going in the y direction? Okay? Did you bring me supper? Chocolate? I got nothing from you guys. I'm not doing this anymore. Nothing. Not even any chocolate. I'm done.
I'll still get to you before the test.
I have
Yeah.
That's not bribery then. All right, we're good with this? Guys, I just did number 4. Did you need any help with 4? Before I erase it? Since you showed up, I said we don't have to worry about bank problems. I said we don't have to worry about bank problems. Any other ones you want me to go through?
Could you do 16, so 7?
Give me the one they're reading.
The rotor ride.
Rotor ride.
The rotor ride?
I got
The rotor ride?
Yeah, I got the velocities and for the time, or, yeah, the period, I.
Would you like me to do everybody want me to do the rotor ride?
Yeah.
Rotoroid, where the floor falls out, has a radius. 1 point meters is r. And we can say that this thing is 3-dimensional, and then there's no floor. And there's a person stuck to the wall, right? And there's no floor, and miraculously this person does not fall. Okay? So if I look at this, what type of forces are acting on this person on the wall? Which one can we never get rid of? So force of gravity is going down. If he or she is not standing on the surface anywhere, but she is touching a surface, what's that force if you're touching a surface? Normal. Normal. Where is the normal force going in this ride?
Off the wall.
To the wall. What did you say, Baker?
You said off the wall.
That's what I meant.
Sure.
Some people are off the wall all the time. And because this thing could slide, okay, what's preventing it from sliding down? There is a force of friction working against this force of gravity. So I'm going to ask this question. What's keeping this person stuck to the wall? The normal force. What is keeping this person from falling straight down? The reason why we have to make those statements is, you guys, if I'm saying what prevents this person from sliding straight down, the normal force is not in the Y, so we can't say the normal force. So I can say what's stuck to the wall, okay? The only thing that's sticking me to the wall is the normal force, because that's the only thing in that direction. Okay, now continuing on with what I have. So I can say that's my force diagram. Oh, by the way, we're doing, what did we say? This is 7. What else is given to us? Radius, coefficient of friction is 0.4. Mass is 75. And I want the period.
And you're doing the radius.
Right? Is that what I want?
Yeah, you have radius of 1.
Yeah, I already have that there. So again, since I have friction, I automatically think of this. Just to know that I'm going to probably use zoom to be in a little more, right? Okay, I'm going to probably be using that. Okay, so what is, if I'm looking at my force
That's good.
net in the x direction, what do I have going on? This normal force. What's happening on this ride, by the way? People are moving in this direction. The ride is spinning in this direction. Again, what is that telling you about acceleration? It's in the x. So is this equal to mv squared over r, or we want period, right? So I can say this is mass times acceleration, and honestly, since we want period, what is that equation for period?
4 pi squared. Oh wait.
4 pi squared something.
Yeah.
2 pi r over
It's 2 pi r over v.
Oh, what is it? Look up your area, not your velocity. Or not your area. Your acceleration. Velocity is 2 pi r over something. This is, and I need mass there too, right? Okay, so mass times 4 pi squared r over t squared, because ultimately I want t. So that's why I wanted to jump to that equation. Okay? Now, force net in the y direction is what? What's going on in my y direction?
Force of friction minus
Force of friction minus force of gravity. Is there acceleration of my people going up and down?
No.
So what do we know about that?
0.
That's 0. So what can we say from here? Force of friction equals gravity force. Now, if I look at these two equations right here and right here, ultimately again, look to see what we're looking for. I want period. So can I find period by whatever I have? Do I have no normal force? Nope. I know mass. I know 4 pi squared. I know the radius. I don't know period. So in this problem, equation, I don't know two unknowns. I can't solve for that. So I look at my next one. Force of friction is equal to Fg. But I also know force of friction is equal to this equation right here, right? So can I solve for normal force if I do this? So a force of friction is equal to mu times normal force. And my force of friction is mass times gravity. And I know mu. Can I solve for normal force? Everybody with me on that? So force of friction, we said, is Fg is equal to mu times normal. So mg is equal to mu times normal. I believe my mass again was 75 kilograms. times 9.8 meters per second squared is equal to 0.4 times the normal force. Do some calculations on that, tell me what you get.
Is it good or?
My normal force is what? What'd you guys calculate? I got 919 newtons. Is that what you guys got?
No, 1,800.
Yeah, that's what I got.
75 times 9.8 divided by 0.4.
Yeah.
It's 1,000.
What is wrong with my calculations? 75 times 9.8 equals divided by, oh, I used 0.8 instead. Where am I getting my numbers from? So 1838, can I say that? For sig figs, we shouldn't need any. Did we get that?
Yeah.
All right. I don't know where I pulled 0.8 from, but. So then, since I know normal force, can I put the normal force back in here and solve for period? So that's what I'm gonna do. So normal force is equal to mass times 4 pi squared r over t squared. I can now substitute my numbers. I found this to be, so this answer is going to be wrong too. Maybe if your teacher would make math problem. 75 kilograms times 4 pi squared, and my radius was, I erased it, 1.8?
1.8, yeah.
1.8 meters. Divided by t squared. You guys do the math to make sure you know how to do it. And I'll do it because I'm wrong.
I think your answer may be wrong.
Well, my answer is going to be wrong because this is wrong.
Oh.
Right? Right?
Yeah.
So that's why I'm saying we better all figure this out because my answer is going to be wrong now.
Got a smart aleck back there. .9 seconds. I didn't take it, screw it. 1.7 seconds.
Yeah.
Wait, the square root?
It's t squared. Hey, maybe you should get some contacts or glasses so you can see my board.
No, but I actually went up there. Haven't you seen me go up there during class?
Are we good with this? Sorry that it was wrong. I should probably change that so I can change that language. That's, did you figure that out or did you have a question?
Yeah, no, I got it.
Okay, on your online notes, it was like, we got a different equation. It was mu equals GT squared over 4 pi squared r. And you get the same answer.
That's fine. They just jumped ahead and did that force of gravity thing right away.
Okay.
Whatever works for you.
Okay.
Where's the pen? Oh.
Are we good at this one?
Just plug it all in. Just do 75 parentheses forward.
Next.
I'll do that.
Could you do
And then divide that by that.
beat for, I got.
What number are we
the
looking at?
bucket,
The bucket one?
so 2 or 11. Yeah, could you do that whole one? I got the top part, but then I didn't get the bucket one. I'm not feeling this bucket one.
Divide. Oh,
By
that's what I can
1/8.
Alright.
So the first problem?
Yeah. Yeah.
And then you square. Which one are we looking at?
That's a lot of addition.
Yeah.
And I still don't have my Christmas card written. That's getting done when I get home. So this is problem 2, the buckets. Right? A 1.4 kilogram bucket is held by a string and whirled in a vertical circle. Wait for it. Doesn't that look like a bucket? And on the bottom of it is another bucket. That looks kind of like a ghost or something. Well, you know, buckets have rings on them. Okay, those are buckets.
Holy bucket.
Mass equals 1.4 kilograms. The radius is 1.3 meters. The speed of the bucket, velocity is 3.9 meters per second. And at the top, better put this right. So V up here is 3.9 meters per second. V down here is 7.3 meters per second. Show a diagram. Where's my diagram? For the top, calculate acceleration and tension, and for the bottom, do the same. So, now, let's look at our forces at the top and the bottom. What's my force at the top?
I don't know how to do that, so.
In this case, my force of gravity is down, and my normal force. Excuse me. Is this on a track?
No.
Is this on a surface? If it's not on the surface, we don't have a normal force in a bucket thing. What do we have? What's keeping the bucket?
Gotcha.
Wait for her. What is keeping Barbie in this circle?
Gotcha.
The tension. So, it's not normal force like a roller coaster ride, it's tension. At the bottom, what do we have going on? So we're going to say that this bucket's hooked up to this, right? Force of gravity is going down, it's going up. Tension. Okay. So, at the top, I'm looking here. What is my net? By the way, it asked for the acceleration first. Can we figure out acceleration right away? Acceleration is v squared over r, right? So I can figure out acceleration without doing anything else, right?
Yeah.
So 3.9 meters per second squared divided by 1.3 meters. My acceleration is...
11.7
Oh yeah, this answer was wrong on the answer key too. Did you realize that? Somebody caught that. That wasn't until second hour though. Because again, I put a different number in there. Oh, actually, it's, for the bottom, it's wrong. Because I put a different number in there again. That was second hour. Somebody thinks Josh caught that. So now my question is, when I look at forces, what is my net force? Let me ask you this. Is there any net force, if we're swinging the bucket this way, is there any net force when we're looking at the straight top and the straight bottom in the X? So there is, in the X, there is none, right? If we're saying at the top. So what's my net force in the Y, in this case? Now, what did we say about centripetal acceleration and centripetal forces? Where is the force, net force, always going to? The center. So the net force has to be going to the center. Both of these are going to the center, right? Luckily, otherwise, Barbie would have not stayed in my circle. So what do we know about this then?
FG plus
FG plus FT will equal?
mv squared over r.
What do I want in this one? I want the force of tension. What's FG? MG. I'm looking for FT. Do I know mass? Do I know velocity?
Yeah.
Do I know R? Can I just plug and chug now? So mg plus ft is equal to mv squared over r. So I'm going to substitute in 1.4 kilograms times 9.8 meters per second squared plus ft is what I'm after is equal to 1.4 kilograms times velocity squared 3.9 meters per second squared over r, which was 1.3 meters. Solve for ft. And
Wouldn't we be using 7.3 for the velocity since it's on the bottom?
say that again.
For the velocity, isn't it 7.3 for the bottom?
Oh, thanks. Good catch.
Ooh, solid one right there.
I'm on the top though.
Oh, okay.
So I'm like, right.
Not solid one down there.
I was actually right this time. Did you give you a force of tension yet? 2.66 newtons. So my force of tension in this case is 2.66 newtons. And I'm going to tell you that letter B is wrong in my answer key because I used a wrong number. We're good with this one? So just in comparison, I just want to put this up here, that my force of tension is equal to 2.66 newtons. Because I think it's interesting to compare those numbers. At the bottom is letter C. So for letter C, we have force of tension going into the circle and gravity going out. Right? By the way, they asked for my acceleration right away. Can I do that? Can I do acceleration right away?
Yeah.
Yeah.
Acceleration is v squared over r, so acceleration is 7.3 meters per second squared divided by r is 1.3 meters. This one, I think it's corrected. 41 meters per second. I can't remember if that's exactly what you guys told me. I trusted that. Do this math, because I don't know if the dude that told me was right. Huh? I said my answer key's wrong, so make sure this is right. Because I don't know if the dude that told me I was wrong was right. Good thing you're paying attention, Josh. Is this what you guys got?
Yeah.
Because I forgot to square it, so that's why my answer's wrong. See again, if you guys show me all the work and I see that you're missing this square, how many points are you going to get off your whole problem if you miss this square?
0, because
One.
you love us.
1. If I don't follow your work and I have
Everyone
no
has those
idea
days.
where your numbers come from, you're getting a lot more points off. But if I can see that this is where you're thinking and you forget these little squares, it's -1. And then I truly look at your numbers and recalculate on the bottom to see if you got the right number at the bottom. Okay? So, what is my net force in the y direction this time? So I'm looking at this picture right here. Which one's going to the center? Force of tension. So therefore, what does this have to be then? Force of tension minus force of gravity. Does everybody understand the difference? Because you guys, this is the same idea with roller coasters. It's the same idea with this bucket thing. That the one going to the center has to be more positive because the net force for circular stuff has to be going into the center, because that's where acceleration is.
So on top it's plus.
And due to
bottom
the fact
minus.
that force net is equal to mass times acceleration, the acceleration and the net have to be together. It's a direct proportion. Because we're not going to change mass. Okay? All right. Is there acceleration here?
Yeah,
So is this equal to 0 or mv squared over r?
mv squared over r.
And ultimately, I want my force of tension this time. Here's what I want. So if I want to solve for that, force of tension is equal to mv squared over r plus mg. Can I make that leap from force of gravity as mg? Do I know everything? Do I know mass, velocity, r, and g? So now it's just plug and chug. Mass was 1.4 kilograms. Again, this answer is going to be wrong because my acceleration was wrong. V is 3.9 meters per second squared divided by my 1.3 meters plus my mass was 1.4 kilograms times 9.8. What is my force of tension at the bottom? Figure that one out for me.
Isn't it 7.3?
Yeah.
We're doing the bottom. The bottom 7.3.
Well, now you guys can fix me.
Yeah.
Yeah, no.
Adam, you missed that one.
Yeah.
I did right. Did right over there.
Yeah, I think it's.
I'm gonna try to get more than 4.5 hours of sleep tonight.
Sounds good.
I doubt it's gonna happen though. Alright? So, got an answer for me?
Times 1 point.
Yeah, round off here.
Yeah.
I just wrote
So what can we say about the force